Hey guys, so this is actually a video request. I was requested to find more asymptotes using limits. So in this video, I'm going to be going through these three problems, and I want to use really limits to determine if I have any asymptotes. So just as a reminder, a horizontal asymptote. So in this case, we're going to be looking for limits as x goes to infinity. And then for vertical asymptotes, we're going to have the limit as x goes to like some number. And usually that number will be on either the left or the right. So these are the three examples I'm going to go through. Highly recommend that you pause the video and actually try these out on your own. And that will just kind of help you engage with the video a little bit more. But otherwise, let's get into this. So starting with f here. So just a note on the domain. So really x can't equal 0. And usually when you find that number and you've got a rational expression, that's generally where your vertical asymptote is going to lie. So I am just going to do this on one side. So like I said, this is not going to exist at x equals 0. So I have just totally arbitrarily chosen the left side of 0. I could have chosen the right side. So if I go through now and I evaluate this limit, so the big thing that you're thinking about here is what happens, what is actually going on here. So if I plug 0 in, I get 1 over 0, so that's a problem. And then when I also look at this, I notice I cannot simplify this expression any farther. So that really gives me a sense that this will probably equal positive or negative infinity. So the big thing then is, which is it, positive infinity or negative infinity? And there's a couple different ways we've talked about that you can do that. So you could always make a table and you can fill in a couple of x values that are just to the left of the 0, like these three values here. So these are just getting progressively closer and closer to 0. And there's kind of two different ways that you can do this. So once you have that really strong sense that this is going to go to infinity, the big thing is just, which is it, positive or negative infinity? And if I think about plugging these values that are just on the left of 0 into this, well, the top will be positive, but the bottom will be negative. So just by looking at this, I can see that this is probably going to negative infinity. But if I'm a completionist, I want to plug in also these values here. I want to just fill out this table. So if I plug in these values, I get these numbers right here. And now I can see just by looking at this, so the closer I get to 0, the more negative this is getting. So this is also telling me this is going to negative infinity. Okay, so there is my vertical asymptote. So I have a vertical asymptote at x equals 0. Now, BT dubs, if you did this from the right side, you would get that this goes to positive infinity. And that's fine. Really, once you kind of get infinity on one side, that's at least kind of confirming the point, right? Okay, so we've got the vertical asymptote. So next thing's up, now we got to think about the horizontal asymptote. So now we've got to evaluate this guy as the limit goes to infinity. So let me make some space. And let's go ahead and let's set this up. So we've got the limit as x approaches infinity of the square root of x squared plus 1 over x. Okay, so now here is a case where I have to be a little bit careful. So I do want to do that trick where I'm going to divide everything by x, but I have to be careful to think about what is actually the largest power here. So you might say, oh, I need to divide everything by x squared. But remember, this x squared is actually being captured in this square root. So if I think about just how that's going to play out, at some point, this is not the true simplification, but if you just think about how these two things play with one another, it's kind of like this is really just like having an x here. So you kind of want to think about how is this exponent playing with the radical that it's under, okay? So that being said, what I want to do then is I want to actually divide everything by just the power of x. So I'm going to divide this by x, and then when I divide this by x, so I don't want to just divide this by x, I actually want to divide this by the square root of x squared. That is equivalent to dividing by x, but that will allow me then to actually do the division in this square root. So now, as I go through and I do this, so I have that this is going to be x squared over x squared. This is going to be 1 over x squared, because notice I've dropped the square root because now I can just kind of push it in here, and then this will be just 1, which now, as I continue through this, so this will give me the square root of 1 plus 1 over x squared, all of this over 1. And now this is no problem to go through, right? So this guy here is just going to go to 0. And I'm ultimately left with, as x goes to infinity, this just becomes a square root of 1 over 1, which just equals 1. Now, make sure you do interpret this. So this will be the horizontal asymptote at y equals 1 in this case. Okay, so moving on to this next one. So hopefully by this point you have kind of a sense of when we have oblique asymptotes. So oblique asymptotes occur when the degree on top is higher than the degree on bottom. And so that's just going to help us to kind of work that out. So we see that we have an oblique asymptote, but we'll talk about that in a second. Let's knock out the vertical asymptote. So where does this expression not exist? So at x equals 3. So where I might want to start then is to take the limit as x approaches 3. Now we'll just do it on the right this time. So of x squared minus 4 over x minus 3. So now you can see just by looking at this that you're going to get, if I plug in 3, I'll get 5 over 0. Okay, so that's a problem. You can't just plug that in. So we're going to have to do a little bit more evaluation. Notice that once again, you cannot simplify this any farther. So now we've got to use our other methods. So really, is this going to go to positive infinity or negative infinity? So once again, if I wanted to, I could set up a table if I just want to be like a total completionist about this. And I could get just to the right of 3 and just get progressively closer to it. But the bigger thing here is to really think about what is the sign of this going to be as you plug in these values that get closer and closer to 3 on the right. So if I plug closer to 3 on the right, what's going to happen with the top? Is the top ultimately going to end up as something positive or negative? This will be, so this number squared, this is something just over 9 minus 4. So this will be positive on top. And then these are all numbers that are just above 3. So if I plug those into the denominator, it's something just above 3 minus 3. So this also stays as positive. So this is really enough to tell me that this is going to equal positive infinity. But again, if I want to be a completionist about this, I can also fill in my table to get these values. So there you go. So you can see now by plugging everything in, so this is getting progressively larger. So we know that we've got then a vertical asymptote at x equals 3 because this equals positive infinity. So that would be how you use limits to justify that. Okay, so now to the other asymptotes. So now if I just want to think about what happens as I take the limit as x approaches infinity. So I've got this, and so here's kind of the deal with this. If you divide everything by the highest power, so this is x going to infinity, so if I divide everything by the highest power, so I have the limit as x approaches infinity, I divide everything by x squared, so I get 1 minus 4 over x squared, and then 1 over x minus 3 over x squared. So just as a reminder, why is it that we have to do the long division? So this is actually what's kind of telling us we have to go a little bit deeper with this. If I evaluate all of this to infinity, this whole denominator, both of these parts both go to 0. This goes to 0. So what I end up getting is 1 over 0. And that's a problem, right? So that's not going to work. So that's what's actually telling me I can't just kind of do that divide everything by x squared trick. So what you can do then is you can use long division just to kind of help you wrap your head around it. So let me clear some space. So I can go ahead and do this, and I have, so let's see, I have x goes into x squared x times, so then x times x is x squared, and then this will be minus 3x, so I need to subtract all of this off. So I end up getting, so be careful with this, this is 3x, right? So this and this will give me positive 3x. This is not an x here, right? This was minus 4. So this will be 3x minus 4, and now I repeat the process. So what do I multiply x by to get to 3x? That'll just be 3. So this will be plus 3. So then I get 3x, oops, minus 9, and I subtract all of this off. So I get just 5. So what that tells me is that this limit I can actually rewrite as the limit as x approaches infinity of x plus 3 plus the remainder of 5 over x minus 3. So now I can go through and kind of evaluate this. And so this guy right here, this 5 over x minus 3, this is going to end up going to 0. So let's just note that. That goes to 0. This part right here will just go to 3, which is like whatever. And then this x right here, this is going to end up going to infinity. So that tells me that this entire expression right here is going to go to infinity. So I have an oblique asymptote. This is the oblique asymptote. And this is also kind of telling me what is happening as the limit goes to infinity, if that's something that you're asked. This is kind of something a little extra that I didn't really need to do. Like I really could have just said, oh, here's my oblique asymptote. But this is maybe just something like a good note. And then just another thing, I've gotten a few questions about this. So what would happen as x goes to negative infinity? Well, you'd still have this same thing, right? Except now this whole thing would be going to negative infinity. So that just tells you a little bit about how the function behaves, or like its end behavior. So anyways, so final answer. So I have an oblique asymptote at y equals x plus 3. And didn't technically really need my limit at infinity in this case, but just rounding that out. Okay, so now for this last piece. So notice for this function, so we might want to just write it in its factored form. So this is x minus 1 and x plus 1. Okay, so I can see just by looking at this, so I'm going to have vertical asymptotes at plus or minus 1. So I'm going to show, let's see, I've got probably vertical asymptotes at x equals 1 or x equals negative 1, because those are the two spots that will make the denominator equal 0. So I am not going to show you how to do this for all of these. I'm just going to choose one of these at random. So if you're on a test or something, you probably have to prove all of them. But just so I can get through this, I'll just do one. So I'm just going to randomly choose 1. And we want to take a look at what happens for 1 on the right. So let's see. Can I actually prove that 1 is a vertical asymptote? Hope so. Okay, so same thing here, right? So I can once again just kind of set up my little table here. And at this point, you kind of know we can go through and plug in some values. But once again, so the big thing here is just, does this end up being positive or negative? So I'm going to omit doing all the work on the table here and just kind of go into the signs. So if I plug all of these values in on the top will stay positive. And then what about the bottom? So I'm putting all of these things in. So these are all just a little bit above 1, and then I'm squaring them. So this will also end up staying positive. So I can tell just by looking at this that this is going to go to positive infinity, but you can always fill in a table, right, just to kind of be complete with that. Okay, so now let's talk about the other asymptotes. So I'll clear some space. So let's see, why don't we take the limit as x approaches negative infinity this time? I've only been doing it in one direction, so I'll do it this way. Okay, so I've got that. So if I divide everything just by the highest power in this case, so this is actually a nice easy peasy limit in this case. So I divide everything by x squared. So this will become 3 over x, this is going to be 1, and then this is going to be 1 over x squared. So maybe I'll just note that here. So I divide by x squared. And so in this particular instance, what I end up getting as I evaluate my limit as x goes to infinity, well, this will go to 0, this will go to 0, this will stay at just 1. So ultimately, this equals 0 over 1, which just equals 0, which is totally fine. And so that would mean that I have a horizontal asymptote at y equals 0. Okay, so that covers it for this set of examples. You guys have more questions? Drop them in the comments. Thanks for watching.